Welcome to this special lecture on concentration terms. In this lecture, we shall discuss what are concentration terms and few numericals based on them. Before watching this lecture, do watch my video on mole concept topic, as it will help you with the numericals of this topic. So let's start by understanding what are concentration terms. Concentration terms are used to find the amount of solute or solvent present in the solution. So as you know that every solution has two components, solute and solvent. Solute is the component of the solution which is less in quantity, and solvent is the component of the solution which is more in quantity. So on basis of all these three things, solution, solute and solvent, we have various concentration terms. So concentration of solution can be expressed in any of the following ways. First, mass percent or weight by weight percent. Second, mole fraction. Third, molarity. And fourth, molality. So let's discuss each of them in detail. First, mass percent or weight by weight percent. So mass percent is equals to mass of solute divided by mass of solution into 100. So let's understand mass percent with the help of an example. So if I say that a solution of NaCl in water is 5% by weight percent. So what is the meaning of this line? This means that in 100 gram of solution, 5 gram of NaCl is present. So solution of NaCl in water by 5% mass percent means that in 100 gram of solution, 5 gram of NaCl is present. So now let's practice a question based on mass percent. The question says that a solution is prepared by adding 2 grams of substance A to 18 grams of water. Calculate the mass percent of the solute. So in this case, you can see that the solute is substance A and its mass is 2 gram. So mass of solute is equals to 2 gram. Similarly, the solvent is water, so mass of solvent is equals to 18 gram. Now there is a relation between the mass of solution, solute and solvent. That is, mass of solution is equals to mass of solute plus mass of solvent. So we know that mass of solute is 2 gram and mass of solvent is 18 gram. So mass of solution becomes 2 plus 18, that is 20 gram. So now mass percent of A will become mass of solute upon mass of solution. So as solute is A, so it becomes mass of A upon mass of solution into 100. So therefore, by substituting the values of mass of A and mass of solution, we will get the answer as 2 by 20 into 100, that is 10%. So the mass percent of A is 10%. That means that if we take 100 grams of solution, then in that 10 grams of A substance will be there. Now let's discuss the second concentration term, that is mole fraction. Let's understand this with the help of an example. So let's take a solution with two components A and B. In the solution, A is the solute and B is the solvent. And there is 1 mole of A and 3 moles of B in the solution. So we have to find the mole fraction of A and B. So for that, we will do nothing, but in the numerator, we will take the moles of A and divide them by the total moles. So as there is 1 mole of A and total moles are 4, so mole fraction will become 1 upon 4. Similarly for B, it will become 3 upon 4 as there are 3 moles of B and total moles are 4. So by this example, we have got the formula of mole fraction. So mole fraction of A will become number of moles of A divided by number of moles of solution. That is number of moles of A divided by number of moles of A plus number of moles of B. So if we denote number of moles by symbol N, so mole fraction of A will become Na divided by Na plus Nb. Similarly, mole fraction of B will become Nb upon Na plus Nb. So mole fraction of anything will become number of moles of that thing divided by total number of moles of the entire solution. So now let's discuss a numerical based on mole fraction. So the question says that find the mole fraction of NaOH if 40 grams of NaOH is dissolved in 54 grams of water. So first, to find mole fraction, first we will have to find the number of moles of NaOH and H2, because only then we will be able to find the mole fraction. So as I have told you in mole concept video, that the formula for number of moles is that number of moles equal to given mass upon molar mass. So using this formula, we can easily calculate the number of moles of NaOH and H2, and then we will put them in the mole fraction formula and we will get the answer. So first let's find the number of moles of NaOH. So number of moles of NaOH is equal to, as given mass is 40 gram upon molar mass. So first we will have to find the molar mass or atomic mass of NaOH. So for that, we know that mass of Na is 23, O is 16 and H is 1. So the total mass of NaOH becomes 40. So in molar mass we will replace by 40. So number of moles of NaOH are 1. Similarly, we will find the moles for water. So number of moles of water equal to given mass, that is 54 gram upon molar mass. So to find molar mass of water, we know that molar mass of hydrogen is 1 and for oxygen it is 16. So as there are two atoms of hydrogen, so we will multiply the mass of hydrogen by 2. So therefore, the mass of H2O or water becomes 80. So molar mass of H2O is equal to 80. So number of moles of H2O are 3. Now we will just replace the number of moles of NaOH and H2O in the mole fraction formula. So that formula says that mole fraction of NaOH will be number of moles of NaOH upon number of moles of NaOH plus number of moles of water. So this will become, as there is 1 mole of NaOH, so 1 upon 1 plus 3. So this will become 1 by 4. So similarly, we can find the mole fraction for water. So mole fraction of H2O will become number of moles of H2O, that are 3, upon number of moles of NaOH, that is 1, plus number of moles of H2O, that is 3. So it will become 3 upon 4. Now one important thing to observe is that the mole fraction of all the components of the solution will be equal to 1. So in this solution there were two components, NaOH and water. So mole fraction of NaOH plus mole fraction of water will be equal to 1. So you can see that mole fraction of NaOH is 1 by 4 and mole fraction of water is 3 upon 4. So you can see that 1 upon 4 plus 3 upon 4 is equal to 4 upon 4, that is equal to 1. So this is the important relation that mole fraction, the sums of mole fraction of all the components of the solution will be equal to 1. So when I found out the mole fraction of NaOH is 1 upon 4, then I don't need to find out the mole fraction of H2O. If I just subtract this mole fraction of NaOH from 1, then this will be equal to 3 upon 4, which is the mole fraction of H2O. Now let's discuss the third concentration term, that is molarity, denoted by capital M. Molarity is the number of moles of solute in 1 liter of solution. So formula of molarity becomes molarity is equals to number of moles of solute divided by volume of solution in liters. Now let's understand molarity with the help of an example. So if I say that the molarity of sugar aqueous solution is 2m. So this means that 2 moles of sugar are present in 1 liter of solution, because molarity is the number of moles of solute in 1 liter of solution. So in this case, as sugar is the solute, so molarity becomes 2 moles of sugar are present in 1 liter of solution. So I hope that definition of molarity is clear. Now let's practice few numericals based on molarity. So now let's discuss few questions based on molarity. The first question says that calculate the molarity of NaOH in the solution prepared by dissolving its 4 gram in water to form 250 ml of solution. So you know that formula of molarity is number of moles of solute divided by volume of solution in liters. So here we are not given the number of moles of solute, that is NaOH, but we are given the mass of NaOH. So from that we can easily find out the number of moles using the number of moles formula. So number of moles of NaOH will be given mass, that is 4 gram, upon molar mass of NaOH, that is, as we have calculated earlier, 40. So there are 0.1 moles of NaOH, or 4 upon 40 moles of NaOH. Now next we have to find the volume of solution. So we are given the volume of solution in milliliters, it is 250 milliliters, but we have to convert it into liters. So we have to do 250 divided by 1000. This will be the volume in liters. So basically now the final molarity will be equal to 4 upon 40, that is number of moles of NaOH, divided by 250 upon 1000. So now you just need to do the calculations and you will get the final answer as 0.4 molar. So molarity of NaOH is 0.4. Now here we have another numerical which is a combination of two concentration terms. The question says that find the molarity of 10% weight by weight aqueous solution of H2SO4 if density of solution is 1.1 gram per ml. So this time we are given the weight by weight percent of the solution, and from this we have to find the molarity. So how we will do that? First let's write that what does 10% weight by weight solution mean. So 10% weight by weight solution means that there are 10 gram of H2SO4 in 100 grams of solution. So in 100 grams of solution, there will be 10 grams of H2SO4. Now, for finding molarity, we need two things, that are number of moles of solute and second, volume of solution. So number of moles of solute, that is H2SO4, will become number of moles of H2SO4 will become given mass, that is 10 gram upon the molar mass. So to find molar mass, we know that hydrogen it is 1, for sulfur it is 32, for oxygen it is 30. So as there are 4 atoms of oxygen, so it will be 16 into 4. So basically the total mass will become 1, and again in hydrogen there are 2 atoms, so it will become 1 into 2. So total mass will become 2 plus 32 plus 64, that is 98. Total molar mass of H2SO4 will become 98. So number of moles of H2SO4 will be 10 upon 98. We need not do the find the value in decimals, because it will get cut when we will put it in the equation. Now we have to find the volume of solution, because that is the second thing we need to find molarity. So here we are given the mass of solution but not the volume. So from mass we can find the volume if we know the density, because density is equals to mass by volume. We are given that density of solution is 1.1 gram per ml and mass we know is 100. So from here volume can be found out as 100 by 1.1 ml. So to convert, we have to convert this volume in ml into liters. So it will become, we will have to divide it by 1000. So it will become 100 by 1.1 into 1000 liter. Now here we have the volume, here we have the number of moles. Just put it in the formula of molarity and get the answer. So molarity is equals to number of moles of H2SO4, that are 10 upon 98, divided by the volume of solution in liters, that is 100 by 1.1 into 1000. So this is our final answer. Just do the calculations and you will be able to find the answer. Fourth, molality, denoted by small m. Molality is the number of moles of solute present in 1 kg of solvent. So it is slightly different from molarity. In molarity means the number of moles of solute present in 1 liter of solution. But in molality, we have number of moles of solute present in 1 kg of solvent. So the formula of molality becomes number of moles of solute divided by mass of solvent in kg. Now let's understand it with the help of an example. So if I say that molality of HCl aqueous solution is 3m, this means that 3 moles of HCl are present in 1 kg of water. So let's solve a question based on molality. The question says that density of 3 molar solution of NaCl is 1.25 gram per ml. Calculate the molality of solution. So this time we are given the molarity and we have to find the molality. So molarity is equals to 3, and this means that 3 moles of solute, that is NaCl, are present in 1 liter or 1000 milliliter of solution. So if we take 1 liter or 1000 milliliter of solution, then we will get 3 moles of NaCl. This is given to us. And from this data, we have to find the molality. So formula of molality, small m, is number of moles of solute, that is NaCl upon the mass of solvent in kg. So here the solute is NaCl, and as it is an aqueous solution, so this means that NaCl is the solution in water. So the solvent will become water. So here we will have to find the mass of solvent. So for that we will apply the number of moles formula, because from that we can get the mass. So basically number of moles of solute. First let's find the mass of solute. So that will be equal, because the formula says that number of moles is equal to given mass upon molar mass. So for solute, that is NaCl, the number of moles are given 3. We have to find the mass, and molar mass we can find because mass of Na is 23 and mass of Cl is 35.5. So it will become 23 plus 35.5, that is 58.5. So the mass of solute will become, mass of NaCl will become 3 into 58.5, that is 175.5, and this is in grams. Now similarly we can find the mass of solvent, that is water. But for that first we will have to find the mass of solution, because we are not given the number of moles of solvent. So to find the mass of solution, we know that density is equals to mass by volume. Now density is given to us as 1.25. Mass of solution we have to find, and volume of solution we know as 1000 ml. So mass of solution will become 1.25 into 1000, that is 1250 gram. So from here, by subtract, as we know that mass of solution is equals to mass of solvent plus mass of solute. So from here we can find the mass of solvent. So mass of solvent will become mass of solution, that is 1250, minus mass of solute, that is 175.5 gram. So mass of solvent will become 1074.5 gram. But for the formula we have to convert it into kg. So just divide it by 1000 and this will come out to be 1.0745 kg. So now we have both the things, that is number of moles of solute and the mass of solvent in kg. So now just we have to apply the molality formula. So molality will be equal to number of moles of solute, that is 3, divided by mass of solvent, that is 1.0745. So just do the calculations and you will get that this is equal to 2.79. So the molality of solution is 2.79. So I hope that all the numericals and concentration terms were clear to you. Now I am giving you few practice questions of these concentration terms. You can solve all these questions and give me the answers in comment box. Till then, stay tuned.